Okay, today our topic it's talking about correlation and regression. Today we're going to explain what does correlation mean and what do we mean when we say that two variables are correlated to each other. So by end of this chapter, which will be today and tomorrow, we will be able to explain the concept of correlation. You will be able to calculate Pearson's correlation coefficient and interpret the results. You can calculate Spearman's rank correction for qualitative or rank data. Also, you'll be able to determine the regression equation for a set of data, and you can use the regression equation to make forecasts for valid value of independent variables. So let's start. What does correlation mean? I think most of you already hear about the word correlation earlier, and you know it will explain the possibility of having relation between two variables. So sometimes two variables are found to be related to each other in some ways. A change of one variable might cause another variable to change due to influence influence of the first variable on the second variable. So which means here are two variables that are influencing each other. Let me ask you a question. Any one of you can give me example about two variables that may be influencing each others. Maybe let's say we can say if one variable have increased, the second variable will increase or will be decreased. So if the price of product decreases, the amount of the product purchase increase. Also, yeah, this is a very good example that when the prices increases, when the prices decreases, the purchases of this product is gonna to increase, which means people they're gonna to buy this product more and more. Yes, this is a very smart example. So as we mentioned, correlation, it means two variables are related to each other, which means that the movement of one variable is gonna to affect that movement of the another variable. For example, an increase in the price of sugar may cause the price of certain foods to increase. Like all of us, we know that Tetarek, as example, has the sugar as main component of it. So when the prices of sugar were gonna to increase in a very high percentage, so it means the price of the drink is gonna to increase. Also maybe the price of the jam is gonna to increase because the price of sugar increase. So this is one of the examples about correlation between two variables. Higher sugar prices cause the production cost of these foods to increase. Therefore, food manufacturer may have to increase their selling price. The same applies when petroleum price increases. Petroleum price affects the price of other commodities, products, and services, resulting in a series of chain reaction. Higher fuel prices cause energy prices to increase. Therefore, producers need to increase the selling price of their products and services to cover the escalating operating costs. So this is also another example that increasing in these prices is gonna to increasing in the energy prices is going to lead to increasing in the fuel prices. Sorry, increasing in the energy prices is going to cause increasing in the product prices, because all of us we know that all manufacturers are relying on the fuel to run the factory. So for that reason, increasing in that prices is gonna to lead to increase the price of their production. So from the above examples, we can conclude that two things. First, when an increase in one variable causes another variable to increase, these two variables are said to have a positive linear relationship. As we mentioned, when we say that one variable increased, it means another variable will increase. So it means we have a linear relationship, which is positive relationship. So what is the difference between positive relationship and negative relationship? We can say it's a positive relationship when increasing in one variable, it's going to cause increasing in another variable. We can call it a negative relationship when increasing in one variable, it's going to lead to decrease in the another variable. So, secondly, an increase in one variable may cause another variable to decrease. This is, for example, the relationship between energy prices and companies' profit. As we mentioned, that when energy price is increasing, it's gonna to lead to higher cost to companies, which will lead, if the prices remain stable, so it will lead that the profits of companies is gonna to decrease. So these two variables are said to have a negative relationship. Correlation analysis is a statistical method used to measure the strength of the relationship between two variables, while regression analysis is a statistical technique that can be used to obtain the equation relating to these two variables. So correlation, as we mentioned, we want to know the difference between correlation and regression. So the correlation is used to measure the strength of the relationship between two variables. Measure the strength of the relationship between two variables, while regression analysis is a statistical technique that can be used to obtain the equation relating to those two variables. Because when we have relation between those two variables, so we can obtain an equation to measure the movement of one variable, which we call it a dependent variable, when something change in the independent variable. So this movement of this relation, we can show it in what we call it a scatter diagram. Scatter diagram. Okay, first, any question about the correlation? Any question about the correlation? Okay. So as I have explained, the correlation, it means there is a relation between two variables. If one variable change, the another variable also will be changed. So this correlation maybe goes as positive or as negative, which means maybe the movement of one variable, increasing of one variable, it's gonna to cause to increase in the another variable. This we call it is a positive correlation. Or as a movement of one variable increasing in one variable is going to decrease in the another variable. So this is we call it a negative correlation. Okay. So the regression is a statistical technique that can be used to obtain the equation relating to the two variables. Okay. So the scattered, as I mentioned, this correlation, we can explain it in what we call a scatter diagram. So the first step in determining whether a relation exists between two variables is to plot a graph for the data. So normally the independent variables is labeled in the horizontal, and the dependent variable is going to label as a vertical axis. The paired variables are plotted on the graph. This graph is called scatter diagram. So the first step to determine whether those two variables are correlated or no is to draw a scatter diagram, which is, as we mentioned, the independent variable will be in the horizontal way. So normally, if you want to draw the scatter diagram, we normally put the independent variable in the horizontal axis, and we put the dependent variable in the vertical one. So here is the dependent variable, and here is the independent variable. And normally we're gonna to show the measures in the plot here. So we try to see how those variables are how those measures are increasing or decreasing, to we at least can understand whether there is a relation between those two variables or no, or there is a correlation between those two variables or no. So normally the independent variable, as we mentioned, is labeled on the horizontal axis, and the dependent variable is on the vertical one. The birth variables are plotted on the graph. This graph is called, this one, as we mentioned, we call it the scatter diagram. So the scatter diagram, let me just clear here to be able to read the rest of the slide. So the scatter diagram forms certain patterns, increasing or decreasing, indicating that there is a relation between the two variables. If the scatter diagram doesn't show any pattern, as what I was drawing now, there is no any pattern, so the variables are increasing or decreasing, or they are just acting as there is no relation. So we call it acting randomly. So we call it randomly scattered. We can assume that these two variables don't have a relation. Okay, so when the scattered diagram doesn't show any pattern, it means there's not like all of them moving one line up or down. So we can call it as randomly scattered. So we can assume that those two variables don't have a relationship. If the scatter plot falls in the straight line, we assume that those two variables have a relationship and we has a correlation. And here we can find whether it's a positive or negative. If this straight line is positive in a gradient or slope, then we have perfect positive relationship. However, if the gradient is negative, we can have a perfect negative relationship. And here I'll give you some examples about the scatter diagram. I know this photo is not that much clear, but it somehow shows us the movement of the scatter diagram. If you see, we put the independent variable in the horizontal way, which is the salary, and that dependent, which is the car price. So here the question is what your car says about your salary. So mostly when you're having higher salary, you're gonna to get higher price car. Like if you are like earning 10K per month, maybe you will go to like Saga car, or maybe but if you are earning, let's say 25 or 30K per month, so you're gonna to go like for like Honda Accord or something like this. Okay, so this scatter diagram is gonna to show that the relation between the salary and car price, and this study show that there is a relation, and they are positively correlated, which means increasing in the salary, it goes to increasing in the car price the person like to obtain. So this is one of the example about scatter diagram. This is a positive correlation. We have the negative correlation, which is, as example, the weight and the cost for the two-person backpacking tents. Okay, so normally the backpacking tent, it's preferable to be lower weight, which is because normally people, they have to carry it to work for long distance. So for that reason, they need to have it not that much heavy. So for that reason, they go like more is light, more is expensive. So this is we call it a negative correlation, which means when the weight is low, so the price is high. More the weight is gonna higher, more the price is gonna lower. So this is, yeah, there is a correlation between those two variables, but this is, we call it a negative correlation. So in this graph, we can say we have a positive correlation. And in this graph, we can call it a negative correlation. So this is a tool which we can, this is two examples about the scatter diagram, how it's gonna to explain or reflect the relation between those two variables, between two related variables. So either is a positive correlation or is a negative correlation, okay? So if you remember, let me just go a little bit back for what we learned yesterday. Yesterday we learned that sometimes there is a relation between the two variables. It means when one variable increases, the second one increase, or one variable decrease, the second one decrease, or one is opposite relation, one increase, the second decrease, and vice versa. So this is, we can say there is a correlation between those two variables. As we give an example, the price of sugar and price of some food and beverage in the shopping and the production. So we can say if the price of sugar increase, the price of those products which are relying a lot on sugar will increase. Also, we give another example. If the price of the oil and the petroleum products increase, then the industry gonna to increase the cost, and the industry relying on those products will increase, which is also cause a decreasing in the profit. So here we have a positive correlation and negative correlation. So also we learned yesterday about the scatter diagram. We give some example like the positive correlation we said between the car price and the salary. So more your salary is high, more the car you are driving, more you are planning to get a higher price car to drive. We give example about negative correlation, like the price between the for the like 2-person backpacking tent, the price between the cost and weight. So more is light, more is costly, because the preferable to be light, because people they have to carry it and take it with them for long hiking. So for that reason they're gonna to look for lighter product. So for that reason is lighter is more expensive. Okay, so today we're gonna talk about the linear correlation coefficient, and we're gonna to learn how to calculate that one. So if you remember yesterday, we took the coefficient is gonna to calculate for us the relation between the variables. So linear correlation coefficient provide us with the measures to evaluate the strength of relationship. Two methods are commonly used. The first method is Pearson. Second method is called the Spearman. So Pearson product moment correlation coefficient. This is the name of the method, but you can just memorize it as Pearson. Okay, so Pearson is gonna to which is normally denoted by R. If you see, this is the R. So this small r is referred to Pearson. Okay, Pearson is gonna to calculate for us the correlation between the variables if our data is quantitative. Do you remember when we talk about the differences between quantitative and qualitative? And so yes, as all of you said, that the difference between quantitative data and the qualitative data, that qualitative data can be measured by numbers, but quantitative data cannot be measured by numbers. I know sometimes we are reflecting it to numbers, but at the end is non-numeric data. So we go back to the correlation. As we were mentioning, we have the Pearson and we have the Spearman. So Pearson, we can use it to calculate the correlation between for the quantitative data, while and Pearson will be represented by the letter which is a small r. Then we have the Spearman. So Spearman will be calculating the correlation for the qualitative data. Okay, so Spearman rank correlation coefficient, normally denoted by pi. If you see this one, the p, the small p like this, can also be used for quantitative data. However, if we want to use Spearman for quantitative data, we have to convert the data from quantitative to qualitative. Then we can use the Spearman. So the better is we use the Pearson for quantitative data, and we use the Spearman for qualitative data. So there is some loss of that. So the Pearson moment correlation coefficient is preferred over Spearman rank correlation for the quantitative data. So we have to keep in our mind, when we have quantitative data, so we have to use Pearson. When we have qualitative data, we have to use Spearman's. Okay, so now you'll ask me what is the difference between this one and this one. Actually, each one of it has its own equation to calculate the correlation. Okay, so let's go to the Pearson correlation coefficient. It tells us two aspects of the relation between two variables. There is sign plus or minus for R, identifies a kind of relation. So if R was in plus, it means the relation is positive. If the R was minus, so the relation is negative. So what is the meaning of the positive relation or negative relation? When we say a positive relation, it means when the first variable increases, the second variable will increase. When the first variable decreases, the second variable will decrease. This means a positive relation. When we say, it means both of the variables are moving in the one way, like either both increase or both decrease. So when we have a negative relation, which means when one variable increase, the second variable will decrease, or one variable will decrease, the second variable will increase, which means the movement is opposite each other's. Okay, so for the Pearson, even actually for the Spearman, both of them, they have the positive and negative values. So for Pearson correlation, normally we use it for quantitative data. So you have to keep this in your mind. Pearson, let me just write it for you here. So Pearson will be presented by small r, and also Pearson will be used for quantitative data. Okay, so this is the Pearson. While we said Spearman will be represented by like P, the small p, and it will be used for qualitative data. So the mathematical equation for Pearson is like this. Oops, that much? Yes, is that much. So what is the meaning of each one of those? We have this is R, which is a Pearson, which is the accumulation of x multiplied by y. So we have to calculate x and y for each of the set of observations. Then we do the sum of it, minus sum of x multiplied by sum of y divided on n. N is number of observation. How many observations do we have? Divided on, this is, we call it, I forget what we call this one actually. I forgot what we call this one. Is the opposite of square actually, okay? This one is the opposite of square. This is, so we have the sum of x, the x raised to power 2, which is the square of the x, minus the square of the sum of x divided on n, which is number of observation, multiplied by sum of y minus the square of sum of y divided on number of observation. So somehow this is the equation which we use it for the Pearson. Okay, so how we can do that? You have to do like a symbol using your calculator or even using the Excel to do this calculation. So let's take one example and see how we can do that. Okay. Okay, let's take the example, then we can go back to understand the explanation of the answers. So the example is calculate the Pearson product moment correlation coefficient, which is R, for the following set of data. We have X, we have Y. For X, we have 3, 5, 8, 10, 13, 15, 18, 20, 28. For Y, we have 30, 35, 41, 50, 51, 60, 65, 66, and 70. You need to keep in your mind that each one of those called observation. Okay, these called observation. Okay, so which means okay, why I don't call this one observation and this is second observation? No, it's wrong. Those together are one observation. Why is like this? Because those two things are connected to each others, which means when I observe X having the value of 3, I observe Y in the same time having value of 30. When I observe X having value of 10, so it means Y having value of 50. Let's take it as the prices of petrol, okay? Prices of petrol. So when the price of petrol is 3, I feel 30 ringgit. When the price of petrol is 10, I feel only 50 ringgit. Or like this, okay? How much you feel and the price of the petrol. Or let's say that is the prices of electricity in it's the price of electricity. So this is for by kilowatt, 3 ringgit, and this is the price of our product. So when the price of the kilowatt increase, the price of our product increase. When the price of electricity increase, the price of our product increase. So we will call this as observation. So now, if you remember in our calculation, we have n. N is number of observations. So how many observations do we have in this example? Okay, just 1 minute. So yes, the number of observations here is 9 because we mentioned each set of data is observation. So this 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have here 9 observations. Okay, so let's calculate the Pearson. Let me see where is the equation of Pearson. Let's take it. Okay. So let me go to the Pearson. By the way, Pearson will come with this, it will be small r. This is the icon of Pearson. And this is the equation. We can use this equation or this equation, okay? So the value of this equation, it will be between -1 to +1. -1 to +1. So the result it will be between this range, -1 to +1. Okay, this is the result. What we can understand from this result, we have to take two things. First, if the mark or the sign is plus or minus. So after we do this equation, we do the entire calculation, we need to see whether it is a plus or minus. If the result is plus, it means those two variables are positively correlated. If the result is minus, it means those two variables are negatively correlated. And I already explained what does it mean, positively correlated or negatively correlated. This is first. Second part of the result is a value. So again, the result of the Pearson or Spearman, which is a linear correlation coefficient, it will have the sign, whether plus or minus, and will have the value. If the sign is plus, it means they are positively correlated. If the sign is minus, it means they are negatively correlated. We go to the value. The value should be between minus, as we mentioned, -0.1 to -1 to +1. So the value will give us the strength of the relation. More close to 1, whether in the plus or the minus side, is strong. More close to 0 is weak. So this is what we call it, the linear correlation coefficient. I don't know why I cannot write here. So this is our equation to calculate the Pearson. Okay, as we mentioned, Pearson, it comes with this small letter r, and this is the equation. This is a sum of x multiplied by y. By the way, x is our IV values, y is our dV values. Again, the IV, we put the sign for it small x. The dV is a small y. So the sum of x multiplied by y is a sum of value of x multiplied by y. So we multiply value of x with the value of y, then we take the sum of the values. What sum does it mean? Because here we have many observations. We have many observations, which means many x and many y, many x and many y. Example, if you remember, we were talking about salary and car price. So first observation is person, his salary is 5,000, his car price is 10,000. This is value of x, value of y. Second observation is a person, his salary is 10,000, his car price is 11,000. This is second value, value of x and value of y. Third observation, the person, his salary is 12,000, his car price is 15,000. So like this, we will have many x and many y. So how we put those values, you see here is the sum of x multiplied by y, which means we need to multiply each x with each y. We get the result. Then we take the sum of all of it. Then sum of x multiplied by sum of y. Sum of x values multiplied by sum of y values. N is number of observation. How many observations do we have? Divided on the square root of sum of x square, which means all the values of x, we take the square of it, then we sum those values. Minus square of sum of x, which means we take the sum of x values, then we take the square of it. So you need to be able to read the equation correctly, guys. There is difference between sum of x squared and the square of sum of x. There are two different values, okay? If you see here, it's sum of x squared, which means we take each value of x, we make the square of it, then we sum all the squares. Minus square of sum of x, which means we sum all the x values, then we take the square of the result. Here is same. So reading the equation is very important. So you know what you should do. This is first. Second, how to apply this equation. You have two methods. Either to make it using either manually or using the financial calculator or using Excel. I will show you one example of doing this exercise using Excel. Okay? This is the Pearson Spearman. As I mentioned, the values it will be -1 to +1 and minus if the result, okay, if the result of the equation is -0.7. What do you think? Is it positive or negative correlation?
Negative.
Yes, because the sign is negative. So, do you think it's a strong correlation or is it a weak correlation?
It's weak.
What do you think?
Weakness.
Why is weak?
Because it's minus is negative.
The minus is for the negative. Now we think about the value. I mentioned the value closer to 1 is strong.
It's closer
to 0 is weak.
You said 0.7, right, miss?
I said minus 0.7.
I think it's strong because it's
Is what?
More close to 1.
Yes, it's closer to 1 comparing the 0. So the value, you need to take two different things. The minus or plus, you can write whether it's positive or negative relation. Then the value itself, 0.7. 0.7 is closer to 1 comparing to the 0. So it's strong. If the value was 0.3, only 0.3, the value is 0.3. Is it positive or negative correlation?
positive.
Positive. Is it strong or weak?
Weak.
Yes, good. So the value of a Spearman or Pearson, you have to take it two parts. First part is a sign, whether positive or negative, so you can decide whether it's positive relation or negative relation. Second part is a value itself. So here you need to think whether this value is closer to 0 or closer to 1. If the value is 0.5, we can call it medium correlation. Less, let's say 0.3 is weak, 0.7 above is strong correlation. So like this, we can explain the value, okay? Because you need to calculate, then you need to explain the value which you got. So we have Pearson and we have Spearman. Spearman is for qualitative data. So for that reason, it's called Spearman. Sorry, what is this one? This is the example. I will do this example with you now. But let's go to the Spearman first. Spearman is for qualitative data, so for that reason called Spearman rank correlation. It also has equation. similar to our previous friend, if you see. So Pearson, it's P sign. Spearman is R sign. Spearman is for quantitative data. Pearson is for qualitative data. So the Pearson, this is the equation. I want to tell you something. For final exam, I will give you the equations, but I will give all the equations. I will give you equation of Spearman and Pearson, and I will tell you calculate Pearson as example. So you need to know which one is Pearson, which one is Spearman. Okay? So you don't need to memorize the equation, but at least you need to know which one is which one. Okay? Okay. So Pearson equation is 1 minus 6 multiplied 1 minus 6 multiplied by the sum of di2 square of di. N is number of the observation, n square minus 1. What is a di? Di is the difference between the ranks, and I'm gonna to show you now one example how to do the Pearson and Spearman calculation. This is the example of the Pearson exercise. We talk about Pearson, we talk about Spearman, and we see the equation. So how we can apply this equation in the exercise. So let's see the question first. If you remember, we talk about the Pearson. What was the question? Calculate the Pearson product moment correlation coefficient R for the following set of data. We have values of X connected to the values of Y. Okay? Values of X, values of Y. We need to use this equation. If you remember, we need to use this equation. Okay? So, in this equation, we want values of Y, values of X, and we need N, which is number of observation. Because each value of X with the value of Y posed together, we call it one observation. Okay? So this value with this value is one observation. This is also one observation. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's take those values and start to apply the equation. I will take you to the Excel, because it's easier than using the financial calculator. So this is the values of X. We put it here. Values of Y, we put it here. X squared. Okay, first instead of X squared. This is our equation which we want to have. Okay, which is R equal to sum X multiplied by Y minus sum of X multiplied by sum of Y divided on N, divided on the square root of sum of X squared minus square of sum of X divided on N, multiplied by sum of Y squared minus square of sum of Y divided on N. So let's calculate each part of the equation separate, then we can get the value. Let's start with sum of X multiplied by Y. This is X multiplied by Y. So we have the value of X, value of Y. X multiplied by Y. We have here X multiplied by Y. Here X multiplied by Y. Here also X multiplied by Y. So here we took the sum of the values. Okay? We took the sum of the values. You know how to use the multiply and sum in Excel, right? Guys, you know how to use sum and the sum and multiply in Excel, right?
Yeah, Miss.
All right. I will remind
yes,
again.
miss.
Sorry? Darwin?
No, nothing, miss.
Okay. So here we are calculating X multiplied by Y. What we write? We put equal to X star Y. The star is shift 8. So equal X shift 8. We get the star, okay? Y. Okay, so here we calculate the sum of x multiplied by y. Here x multiplied by y. Then we take the sum. Sum is what? If we go to the formulas, you can see the sum is available here. You just click sum, select the cells, we'll take the sum. So first part of the equation here is sum x multiplied by y. This is x multiplied by y. This is the sum, which is 7,106. Second part of the equation is sum of x multiplied by sum of y divided on n. This is values of x. This is the sum of it. Values of y. This is the sum of it. Divide on n. N is number of observations. So this part of the equation is A11, which is sum of x, multiplied by B11, which is sum of y, divide on 9. If you notice, I put A11 multiplied by B11 on 2 brackets because we should take the multiply, we divide on 9. Actually, the value would not be different, but if there is plus, it will be different value, but it's better you put brackets. This is the first part of the equation, first 2 parts of the equation. Part number 3 is sum of x squared minus square of sum of x divided on n. Sum of x squared. This is x squared. How we take x squared? We choose a value. If you see, I explained to you here how we take the square. We put equal. We choose the cell. We put shift 6. We put 2. It's going to be the square. Okay? So here how we calculate the square of each value of x. Then the square of each value of y. This is for the second part. Let's go for the first part. Sum of x squared. So this is the x squared. This is the sum of it. Minus square of sum of x. This is sum of x. We will take the square of it. Divide on n. How we do this one? If you notice, I already put here. C11. C11 is sum of x squared. Minus square of A11. A11 is the sum of x. We take the square of it, which is divide on 9. If you notice, this divide is not part of this C11. It's only for this side of the cell or this side of the value. We do same for the another part. So now we have this part, we have this part, we have this part, and we have this part. Now let's calculate the bottom part of the equation, which is a square root of multiply of those 2 parts. This is a square root. How we calculate the square root in Excel? It's an equation called equal SQRT. So we put equal SQ. You see SQRT. You double click. You select any value. So this is the square root of this value, the 500. So we take the square root of this multiplied by this. You see SQRT of G8 multiplied by J11, which is this part multiplied by this part. This is the bottom value of our equation. We are talking about this equation. Then we put all the equation here, which is H3. What is H3? This one, which is sum x multiplied by y. Minus I5, which is this value, which is sum of x multiplied by sum of y divided on n. Divide on K14. K14 is entire bottom part, which is this one. We get the value. The value is 0.95. This correlation, positive or negative?
Positive, miss.
Strong or weak?
Stronger.
Yes. So what you need to practice now, you need to practice how to do all of it in the exam. You will have the equation. You have the right to use Excel. So you need to apply this. Okay? If you notice, it's very simple to apply. You need just to know how to do each part of the equation. Divide your equation to small parts. Calculate each part of it. Then get the total value. You can do all of this using your financial calculator, but this is if you know how to use it, okay? I know most of you don't have financial calculator or you don't know how to use it. Tell me, Rohit, any question?
Miss, in the final exam, we don't have to do in Excel, right?
You can do in Excel.
I mean, we don't need to do in Excel. We
How
just
you
have
will
to
do
do
the
in
calculation?
In Word with calculator.
But I want to see the steps.
Okay.
You cannot just give me the total value.
But I don't know how to insert this Excel to Word. I mean, if you ask questions in Microsoft Word, and then we have to insert this answer in Word.
No, in submission, you can submit the Excel file, no problem. You can submit two files, part the Word, which is questions in the Word file, and part is Excel, which is the questions in the Excel. Because also for final exam, one of the question, it will be for the graphical presentation. If you remember when we learned how to do our frequency, how to draw our pie chart and bar chart and these things, you have to do that also on Excel.
Okay, miss, thank you.
Welcome. So for final exam, you can submit two files. One file for questions which are in Word, one in Excel. And also, actually, I will make it easier for you because last semester I did same. I uploaded the questions in our PDF format, and I upload one Excel file has each question in different tab. Like an Excel file I will upload for you in the, because our final exam will be using the assignment tab in our class. So you will have one Excel sheet. Each tab is different question, question number 2, 3, 4, 5. So you just download that sheet. You go to question 1, you put the answers under the question. You press the second tab, you put the answers under the question, you go third tab and so on. Then you rename the file, then you upload. Okay?
Okay, miss.
Okay, guys?
Okay, miss.
Yeah. So again, for the final exam, I will do this one for you because I did last semester and it works very well because some students, they miss, they don't know what to do. So I will upload for you the question in PDF. I'll upload for you one Excel file. Each tab is for different question. So you click tab 1, you'll find the question 1, second tab, question 2, third tab, question 3. Under that, in the same tab, put your answer. Then rename your file and upload. Okay? In the first tab of the Excel file, you will see place to put also your information. Okay? Okay, guys? Okay.
Okay, miss.
Yeah, so
Okay,
this is how to calculate the Spearman. How to calculate the Pearson. Let's go again to the example of Pearson. Yes, let me show you the example of Pearson. Yes. 5 students, A, B, C, D, E, are ranked in 2 subjects, statistics and computer programming, with the following results as shown. So, subject A, statistics, or sorry, the student A, he ranked first in the statistics and third in the computer programming. Student B, he become second in statistics, first in the computer programming, and so on. Calculate the Spearman rank correlation coefficient. If you remember, this was our equation. This is the equation. Let's go back to Excel. This is the students. This is the students. This is the rank in the statistics, rank in computer programming. If you see the equation, Pearson is 1 minus 6 multiplied by sum of DI square. Okay? DI is the difference between the ranks. So what we should do, we should arrange the values based on the one of the variables, like this. If you see, we arrange the students based on their rank in the statistics. Student A, he was the first, student B, he was second, student C was the third, Student D was a 4th, and student E was a 5th. So we arrange them, we arrange the students based on the rank of one of the subjects. The second one is following. DI is the difference between rank, is the rank of the first subject minus the second one. So it's 1 minus 3, minus 2. 2 minus 1, 1. 3 minus 4, minus 1. 4 minus 2, 2. 5 minus 5, 0. This is the DI. So DI, it's related to the difference in the rank. DI is the difference in the rank. How we can find the difference in the rank? We need to arrange them based on the one of the ranks. Like if you notice, we arrange them based on the statistics value, ranking. The first, second, third, and then the student A, he was the third in the CB. Student B was the first in the CB, like this. Then we calculate the DI, the difference in the rank. We do the square of the DI, as I mentioned. The value, the cell, then shift 6 to get this sign. Then you put 2 to have the square. Like this, we put the square of DI. Then what we have? The sum of square of DI. This is the square of DI. This is the sum of it. Then we have N, number of observation. How many observations do we have? We have 5 students. So 5 observations. So we have the value is, what is the top part? 60, which is 6 multiplied by G5. G5 is sum of DI square. Okay? The bottom part is N multiplied by N squared minus 1. N, it's 5. 5 multiplied by 5 squared minus 1. So P is 0.5. Is it positive or negative correlation?
Positive, yes.
Positive, strong, weak, or medium?
Medium.
Yeah.
Medium.
So if you notice the correlation, it's somehow an easy topic, but we need to know how to calculate. I want to mention one point. I will repeat it again later. If you just give me the value, you will get 0. If I didn't see the steps, I will not give you mark. Okay? So don't try that you ask your friend, what is the value? 0.5. You block the 0.5, this is a mark. No, I'm sorry. Because my marking scheme for each part of the calculation has its own mark. So here it's up to you. You want to get 0, you can copy from your friend. You don't want to get 0, you can practice it and learn how to do. Okay?
The last things we want to study is a regression line. This is the regression line. Do you remember the first things I draw here in the scatter diagram? This is this line with it, which is moving inside or moving through most of the observations. This line we call it regression line. So regression line is a relation between x and y, is linear relationship. The regression line is the best fitting line through the points plotted in the scatter diagram in such a way that the line is closest to the points and that line passes through the points x, and there is line on the above of x and line above of y. What does it mean? This x with the line is the means of x. Do you remember when we calculate the mean? You remember when we last class, we calculate the mean or the average, which means we do plus all the numbers, we divide on the number of the values. Okay, let's say we have 10 observations, 10 x's. So we plus all the values, we divide on the 10 number of the observations. Okay, so this regression line normally passes between most of the means of x and means of y. So okay, we are calculating the least square regression of regression line of y on x. The least square regression line of y on x for a set of data will be calculated like this: y is equal to a plus bx. If you remember in the previous things, we calculated the relation. We calculated the Spearman and the Pearson. Here we calculated whether there is a relation or no, right? And whether this relation is positive or negative. Here, when we are calculating the least square regression line of y on x, which means y equal a plus bx, here we are trying to understand if we have value of x, what is the value of y, or if you have value of y, what is the value of x. This is the equation which gonna to help us to find the value of the another variable. If there is a relation between, let's say, if I told you I have the price of the sugar, so calculate for me how much the price of one orange juice from Starbucks as example, okay? You have equation to calculate because there is a relation between the price of sugar and the price of the orange juice in Starbucks. Or let's say there is there is a relation between the petrol price and your expenses. So here we have y equal a plus bx. B, we can calculate it like here. Okay? Here we can calculate B, here we can calculate A. This is the equations to calculate the relation between the two variables. So we mentioned the first, the Pearson and Spearman, is to understand there is relation or no. If there is relation, is strong, is weak, is positive, is negative. This is the Pearson and Spearman. Here, when we are studying this one, the least square regression, when we are studying about the regression itself, we are trying to find the value of one variable by having the value of the another variable. So here we have to put these things, a plus bx. A, we calculate A like this. As we mentioned, what is y? Y is the mean of y values. X is the mean of the x values. The B, we calculated like this. We have also another equation to calculate. So for that reason, I told you, you don't need to memorize the equations. It will be provided for you. You need just to use it for calculation. And as I told you, I'll upload for you a video how you can do this or calculation in Excel. Because I can understand by normal calculator, it's difficult to have all these numbers and do it manually. So Excel is the best choice for you. You have the equation, you have the values, fill the number in Excel, you get the result. But you need to key in correct data to get the correct result, okay? So it will be explained by details in the video using an example. Last things we have it is a coefficient of determination, is the ratio of the explained variation to the total variation. If you mention, I was saying, if we change the price of sugar, the price of orange juice will change. But I want to understand when I calculate the R square, I want to understand that to what percentage I can explain the change in the orange juice price by the changes in the sugar price. Let's say you notice, as I mentioned, there is changes in the prices in the market share for in the exchange market for the Samsung shares. The Samsung shares in the share market or exchange market, the prices changes. And also we notice in launching of a new Samsung Note 20. So I know this variable, the launches of a new Samsung, is affecting the prices of the Samsung share in the market. In this equation, I can find how much changes in this one gonna to cause changes on this one or gonna to give a value of this one. And by R square, which is we call it the coefficient of determination, we can understand to what percentage I can explain the changes in the market share prices by a new launch of product. Because not always or not only the new launching of this product effect on the changes in the prices. Sure, there's a lot of other factors. As example, when I talk about the price of the gold, you notice during the pandemic, the gold was increasing while the US dollar was not affected or sometimes dropping due to the number of COVID-19 cases in US. But here I cannot say that the price of gold increasing only because of Corona. Yes, Corona is affecting a lot, but maybe there's another factors. So the R square gonna to explain to me